Sure. So today I will be talking about recommendation systems, how recommendation systems have evolved with time, why these recommendation systems are very important, and since our focus is on deep learning, how deep learning models are playing a vital role in modern day recommendation systems. We will look at the recommendation systems of some tech giants like Twitter, Instagram, Pinterest. Look at their ranking and retrieval strategies. We will understand what ranking and retrieval strategies are, and we will also finally summarize that what are the lessons we can learn from the final at the end, at the conclusion, what are the lessons we can learn from all these things. So with that, first I will introduce myself. I am Abhishek Mungoli. I work as lead data scientist at Misho, and prior to that I was working as senior data scientist for Walmart, and I have done my studies from triple IT Hyderabad. These are my social media handles, and interestingly I started my content creation journey a year back, and I have been regularly posting over LinkedIn, and whenever I get time I create some videos and post in my YouTube channel Data Track. My videos are more around industrial use cases, that how would Instagram recommendation system works, and how can one train a 7 billion llama 2 model to solve their task. Like recently I have been working on a video where how can a 7 billion llama v2 model can be trained to respond like Sarukh Khan, because Sarukh Khan is known for his wittiness and confidence and the type of replies he gives. So whatever we ask him, he will uh, the LLM will reply in Sarukh Khan's way of replying. So I asked it that what is how is a deep learning model trained. It gave them reference of movies that feed it a lot of movies, and finally you will get a blockbuster model. So this kind of things I keep doing, and I keep posting in videos, and these are some other social media handles where you can reach out to me. Now, starting the today's topic, that why are recommendation systems so important. Recommendation systems are so important because they are ubiquitous and present everywhere, from online shopping to social media and entertainment platforms. These systems use complex algorithm to analyze users past data and come up with recommendations which are more inferred towards user preferences and behavior. For an Amazon type of ad, it can be for an Amazon kind of app, it can be the item recommendation for the users. For Spotify, it can be the music recommendation for the user. For Facebook, it can be the friends recommendation. For Netflix, it can be the movie recommendation. And interestingly, when you search something and the rank ordering in which the document comes over Google, that is also a recommendation. You can call it the document recommendation. And how recommendation systems have evolved in looks and feel. You can see on the left, this is the Amazon page from 1999, where you can see it's a very simple vanilla page with one search box, while the recent day 2023 Amazon page has lot of widgets like related to the items you have viewed, more items to consider, recommendation in Kindle books, and inspired from the recent shopping trends, and so on. So there are multiple widgets, multiple recommendations. Each widget might have its own recommendation, or it can be a global recommendation, and items are filtered out based on widgets. So these are some of the ways in which they could have implemented it. But the point that I'm trying to make, you can see that how things have evolved a lot. And not just the look and feel, the user taste also keeps on evolving. We are becoming more of a mature users. The cringe content won't we won't like it much, right? Or sometimes we will like it also for entertainment. So even our taste and behavior is keeping on changing, and recommendation systems have to compete with that as well. Moving on, in the last slide we saw that how the look and feel of these recommendation systems have evolved. Now also understands how the algorithms have evolved with time. With time, there used to be traditional methods like rule based collaborative filtering or content based filtering, uh, which has now evolved to more complicated ways like metric factorization based enhancement and so on. So first, let's understand what collaborative filtering is. Collaborative filtering can be understood in this way, that for you can think of it as a bipartite graph where you have users and items, and users would have interacted with some items, right? But not all the items. Now, if you consider this bipartite graph where there are users and there are items and the connections between them, there will be many edges which are not connected, and edges here means that user would have not seen a product. If that edge was connected, what would have been the weight of it? If weight was higher, it means user might have higher propensity towards that item which till now user has not seen. That's the main idea, and it can be solved using some rule based methods. In past it was solved, and then content based filtering, looking at the content of the item and recommending similar items to that. And then things got better with the Netflix famous challenge where matrix factorization people discovered. What matrix factorization does is it takes that user item interaction matrix and decomposes it into user cross latent features and item cross latent features. The main idea is that users latent features and item latent features is kind of a vector space where the two are comparable, and if you multiply them or do a dot product of them, if the output comes to be high, means this item is relevant for the user. If the dot product or multiplication value is lesser, the item may not be very relevant for the users. And some of the algorithms which does it are svd, matrix factorization, and so on. But the problem with matrix factorization was that, or is that, this is not a very scalable algorithm. First, you have to multiply two big matrix, or decompose a big matrix into two smaller matrix, and the matrix can be sparse. So there are these scalability, memory issues, and so on. So people came up with better methods to solve it using deep learning, embedding based deep learning methods, which is also called neural correlativity filtering. The idea is simple. Here also you learn the latent distribution, and those latent distribution are called embeddings. It's the vector representation. And one more enhancement over the matrix factorization is that matrix factorization only decomposes the rating or whatever the value you have in matrix into latent features, and it doesn't take explicit user or item features. But in deep learning methods you can give other features as well, like for an item, what is the click through rate, or when was it introduced in the system, what is the rating. So you can pass this kind of user features, item features, and as well as you can even pass the user id or the item id, which are called id based features, and the other type of features that I was just talking about, the non id features. And together you can learn a latent distribution which you can call as the embedding of the entity. And the idea is that these embeddings are vector representations, and they are comparable. And doing a dot product, if it's comes out high, means user is more interested in the item, and if dot product is low, it may not be a very relevant item for the user. Now things have evolved even more. Now we are also looking at the sequential nature of these interactions. So in sequential recommendation, we look at the order and timing of the interaction, not just that whether your user has liked or clicked or rated, but the order in which the user interacted with these items. He first clicked and then he went to some other item, then after a few bunch of clicks he ordered the item. So looking at this interaction also we can get a lot of information. So modern day recommendation systems are also looking at the sequential nature of these interactions. And something that might have come to your mind would be as soon as I said sequential nature, something like transformer or lstm kind of attention mechanism also we can use in this kind of recommendation systems, right? Also we are nowadays building context saver recommendation. Context means that for different users the recommendations may differ, right? This is called personalization. Or context can also be some other context, as in it's a sales day, so the context is of sales, or time of the day of the week. So depending on different context, your recommendations keeps on changing. Reinforcement learning is also getting used a lot in modern day recommendation system. Reinforcement learning is used mostly for two important things. One is uh, to like we already know what users like to browse, but once in a while showing them some of the items or categories which they have never explored before. So for this exploitation exploration trade off, and as well as the user behavior keeps on changing. So rl, what it does, it keeps on changing the recommendations based on users changing interest. And a lot of research is also going around fairness and explainability of these recommendation systems. So in the last slide we looked at how look and feel wise recommendation systems have evolved, and in this slide we looked at algorithmic wise how the recommendation systems have evolved. Moving on, uh, since this talk is more around the modern day recommendation system, we will talk about the some of the most sophisticated techniques which are used now. So basically, if we from the algorithm perspective, the lower side ones, right, which are more latest, we will talk about these modern day techniques which are used in building scalable recommendation system. And when I say scalable, I mean that like Instagram, it is used by billions of users, so you need to generate recommendation at that scale. So we will talk about scalable recommendation systems and how industries build it. So the recommendation systems, as we already saw, are indispensable in filtering out items that the user may be interested in out of huge amount of items. There are billions or millions of items on the platform, and you have to show the most relevant one. Now, these could be, as I was showing in the first slide, this could be the e-commerce product for Amazon, or it can be the music for Spotify, it can be the music for Netflix, movies for Netflix, or it can be documents for Google. So depending on the industry, their the entity on which they operate may change, but the idea is same, that you have to filter out the most relevant entity for a user. The common practice these days is to build these recommendation systems in as a two-phase architecture: retrieval phase and ranking phase. In retrieval phase, what happens is, out of millions or billions of items, you retrieve the most relevant ones for the users. And now let's say out of millions of items, you have the top 1,000 items which are relevant for users. You also need a rank ordering, right? How, in what rank ordering you should show to the user, which items should be shown first, second, third, and so on. So the ranking model, which kicks in after the retrieval phase, ranks these items in order to maximize the conversion. So there are two stages. One is retrieval phase, where the out of millions of items, the relevant items are retrieved, and the ranking phase, where these items are ranked in order to better the conversion. uh, Moving on. So in today's lecture, we will look at the recommendation system of three major giants: Twitter, Instagram, and Pinterest. And we have already seen that recommendation systems are built using two phases, retrieval and ranking. And we will see how these two phases are used by these tech giants to create highly scalable recommendation systems. I will just take a pause if there are any questions. Yeah, if there are any questions, you can just ask, and then we can continue with the session. Sure. Right. So we can take questions at the end, maybe. Now, first we will look at the recommendation system of Instagram. We will look at the explore recommendation system of Instagram. The explore is the tab in Instagram where you can explore a lot of new reels, new content, and you can search for a query, and regarding that query also you will get many media recommendations. So how the explore Instagram recommendation system is built is, it has two phases. One is retrieval and second is ranking. And since Instagram is a big company, very matured org, they, even for them, the ranking is in happens in two phases: the first stage ranking and second stage ranking, where the first stage ranking filters out the further some of the irrelevant items. So we'll understand the whole flow in more details, but just giving a brief in this slide. So first, what happens, there is a retrieval phase. You can see that there are multiple media sources from which you come up with the relevant media for a user. Now, what do we mean by this media source? Now, if I ask you that for Instagram, recommend some item for the user, what will you do? Some media for the user, what will you do? There are multiple ways. You can see that what user has interacted recently, so similar media to that. Or you can come up with what are the recent trends, which are most popular viral videos, show those to the user. So you can come up with different algorithms or different types of content to be shown to the user, right? So each type of fancy algorithms become one of the source. So you can have multiple algorithms from which you can find top k items, and these top k items will becomes the retrieved items for the user. And how to find the best items out of millions of items, we will see the algorithms they use in these sources. But the idea is that there can be multiple algorithms to find interesting medias, and each one of them is one of the source. and then what you do is you just shuffle and merge all these medias and pass to the ranking stage. Now since you have brought out 1,000 medias, right, and we know that like people usually like to browse the top 100 or so on, so out of 1,000 media also you do a lightweight ranking where you figure out that which are the top ones through the
Sir, sorry to disturb you, Abhishek. Please, can you please make a zoom these slides? Participant not able to read. Yes,
sure.
yeah,
Is
it's
it
fine.
better?
No, fine.
Yeah.
Thank
So,
you.
yeah. So the first stage is retrieval. Second stage is ranking. In the first stage ranking, we filter out again the most relevant ones, and then in the second stage ranking, the final rank ordering of the items is decided, and the rank ordering is also decided using a deep neural network, neural network which is designed to solve multitask multi-level problem. We will understand what multitask multi-level problem it's solving, and as a end product of it we will get a lot of probabilities, as in for a user what is the probability to like that media, what is the probability to comment on that media, what is the probability to share that media or save that media. And once we have all the probabilities, what we can do is we can just find how much weights to give given to each of these probabilities, and the final expected value will decide the rank ordering of the media for the user. So just summarizing, there's a retrieval phase where you find the most relevant medias, bring it all in one place. First stage ranking will further boil down the top relevant items, and second stage ranking will have a deep neural network which will find different probabilities, and you will have a value function depending on which the items will be ranked. So now we will look at all of these stages in more details. The first is the retrieval phase. In the retrieval phase, as I was talking just before, that there are multiple candidates, right, and each candidates can be considered as one fancy algorithm. So each algorithm is called a candidate generator. And interestingly, you can have like candidate generators which can be heuristic based or sophisticated ML based. You can have candidate generators which are real time or pre generated ones. So we will look in more details. So where I say heuristic based, you can see that it can be something like the recent media user has followed or liked, interacted, so similar media to that. You, if you have liked a cricket reel, so another cricket reel which is very similar. And it can also be like if we know that the user is interested on topics like cricket, movies or so on, so the content which are very relevant to their interested topics, this couldn't be the heuristic based, right? We just know their topics or we know what they have interacted with, we are just showing similar content like that. While it can be more ML based as well. ML based as in it can be based on embeddings, like the enhanced version of matrix factorization is using neural collaborative filtering or two tower neural network. So we can use this kind of two tower neural network to come up with interesting recommendations as well. So this is more ML based, or it can be graph based as well. So a graph algorithm which will figure out that where the user is there in the graph and which medias are nearby and more relevant to it. So it can be heuristic based or more ML based, and it can be real time or pre-generated. Real time as in like when I say that a media which user interacted with, so similar media to it, the user might have interacted just a second before, right? And you see in Instagram that as soon as you like some video, you start seeing similar videos. So it can be as real time as that. Like user just interacted with some media, and very soon you start generating candidates which are similar to that. Or it can be pre-generated. We know that the user interest won't change drastically over the day, right? So you can pre-generate during the start of the day some reels or some medias which are more relevant to the interested topics or something which are more towards the trends, and recommend them. And one more thing, that the two tower neural network, I will be talking about it in more details because this is um, something which is a lot being researched upon, and every day in Rexis and all the KDDs, all the influential recommendation system conferences, there are a lot of papers around two tower neural network where they would have modified the architecture in some way to better capture things. So the two tower neural network, it's a very scalable and effective way, and it addresses the constraints of matrix factorization. That matrix factorization is not very much scalable. It can only look at the latent features, not the other features of the entities. And also it is very generic. Like different companies may have different type of use cases. It easily fits to different use cases as well. We will look into that as well. So next we will deep understand this two tower neural network for Instagram and two tower neural network in general. Why is it so scalable architecture? So the Instagram two tower retrieval model, as the name suggests, two tower. There are two towers. There is a there is a user tower and there is an item tower. The user tower takes user features. Item tower takes item features. And there can be even non id based features as well. So what do I mean by id? The user features can be something like age, gender, location, and so on, right? But id can be user id, and item can be item id. How that can be used, I will explain that as well. So the idea is that you will have two towers, one for user, one for item. You will pass user features, item features, and come up with embeddings. And the the idea is that the embeddings uh, will be in a vector space where they are comparable. And if the dot product of user embedding and item embedding is high, that means for this item, this item here is relevant. And I will make one clarification that I am using item, media, all this synonymously. So it means the same thing, that content, the content to be shown to the user. uh, Now I will explain things in more details. So let's say the user tower. What user tower will have user features like age, gender, location, what they have recently posted, what they follow, their engagement metrics, and so on. This can be the non-ID features. And there can be the ID features as well. ID can be the user ID. How you can use ID? You can take the user ID and pass it through an embedding layer, right? So for each user, you will pass it through embedding layer. And as many users in the platform, those many this like id to vector conversion it will be needed. So you can pass all the user features, you can pass user id as well if you want to. Like I've seen people use id, not use id, because as soon as you use the id, your model becomes heavy because there will be many users in the platform, right? So but that can also be used. So you can if you are using the id, you can pass the id through embedding layer and other features normally. And then you can concatenate the two things. One is id based embeddings and these features, and pass it through the user tower. Now what it means by user tower, item tower? What are these towers? These towers are nothing but layers of neural network, where you will have some neurons and some non-linear activations and so on. And finally you will have here the embeddings. Let's say the final layer neural network has 128 neurons, then you will have 128 dimensional embedding, right? You can consider that as the embedding. So in this way you get the embedding representation of user. Similarly you find the embedding representation of item. And the overall idea is that they come up in a vector space where they are comparable and their dot product means something. And what it means, if it's high, the for that user this item is relevant. If it's low, for this user this item or media is not very relevant. And in the media tower or item tower, what kind of features you can pass? You can pass features like, for this media, for this reel, what is the caption, what are the content details, how the engagement metric has been, how many users have interacted with it, what is the like proportion, like by view, comment by like, share by like, save by like. In this way you can create features. And hashtags, you can since there will be many hashtags in the platform, what you can do is you can run a clustering on these hashtags and pass the cluster id of that hashtag as a feature, something like that, as a categorical feature. Or even that those you can hashtags you can convert into embedding and pass. So there are a lot of creativity you can show in the this items features creation. You can also have location, time of the media when it was uploaded, and aggregate user engagement data, as I was talking about, how many people have liked, commented, interacted with, and so on. So that you have a rich media features, you have rich user features, and then you are passing it through neural networks, come up with embeddings, which is the vector representation. And if they are comparable, if the dot product is high, means they are important for each other. The user and this media is important for each other. So that's the idea of two tower retrieval model. And uh, bit more details about this model, how it's used in online serving when in real time when the user comes to the platform. What you do is, after this model is trained, you can just chop off, right? You can chop off from middle. You will have the user tower, you will have the item tower. So you can chop off and just uh, use the item tower in an offline way. So what it means is that the items properties won't change a lot, right? It may be possible that more users have liked it, commented on it, but overall the properties won't change a lot. So what you do is, you generate item embeddings in an offline setup. You like morning once, in a batch mode, you will generate the embeddings for all the items and keep it in a vector database. And user might have interacted with some media just 2 3 seconds back, right? And user, we know that the user behavior changes very fast. So this you can keep in real time. As soon as user comes to the platform, you gather all the user features, pass it through the user tower, which is the user neural network, get the embeddings, and from this vector db you can do a fast approximate nearest neighbor search, and you get the candidates means these are the top items which can be shown to the user. So this is the two tower neural network, and one of the candidate generators in the Instagram explore recommendation system. There are other candidate generators as well, but this is very important, as like if you see the weightage of media coming from all the candidate sources, it might be high for this, and many companies are using two tower neural network and they are finding it very useful. We will also understand why these neural networks are very like giving very good candidates in upcoming slides, but that's the overall idea. And one more thing, you don't always have to use the two towers together. Like what you can do is, you can use the item tower independently as well, because when I was saying in the last slide, we can also show media which similar to what user has interacted. So what you can do is, you can just take the item embeddings and find similarity between them, that with this reel, which other reel or which other post is similar. So Instagram also uses item embeddings directly to retrieve similar items to those for a user's interaction history. So in that way, you can either use just one tower and find similar items within it, or you can use the user embedding and find which media are relevant by doing a dot product and showing it. So it's actually not or, it's and, because both are two different candidate sources, right? So in that way, you get more medias to be shown to the user. Now I will take a slight detour from Instagram recommendation system, and I will come back to it shortly, just to tell you the importance of this two tower retrieval model. Why is it so important? So what is a two tower model? It's just a deep learning neural network where you have two entities, you gather their features, pass it through the neural network, which you call as tower. You get the embeddings, and the idea is that they become comparable in the vector space there, and their dot product means something. High means they are relevant for each other, low means they are not relevant. So why is it so generic? It's so generic because it's used for a variety of tasks. For an e-commerce product a company like Amazon or Misho, it can be something like user tower and e-commerce product tower, right? But for Instagram, it can be user tower and media like post, video, reel. For LinkedIn or Twitter, it can be user and user. Which other users are relevant. So for LinkedIn and Twitter, it can be used for friend recommendation. For Wikipedia or Google kind of search companies, it can be query tower and document tower. So in that way, the two tower uh, retrieval model or two tower model is very generic, where the two towers can be any entities, and the idea is same, that we bring them in a vector space where they are comparable. Moving on. So coming back to Instagram's recommendation system, we have shown that in the initial slides that there is a retrieval phase and ranking phase. We have covered the retrieval phase where we looked at multiple media sources, different type of CGs. Now we will look at the ranking stage, and it happens in two stages, right? So moving to the ranking stage of Instagram, in the first stage ranking, they, out of the, let's say, thousands of items, they further filter down to the top 100 items, and they again use a two tower neural network for first stage ranking. But it's clearly mentioned in their blog that even though the first stage model is a two tower architecture, the objectives are completely different. As in here, we are trying to predict the probability of like we are trying to predict whether whether for this item the user will like it or not, or user will comment it or not, something like that. So objectives are very different, and the reason this two tower is used because it's lightweight, and they want to just uh, filter out some of the not so relevant items from the relevant thousands of items. And in the second stage ranking is where a deep, heavy MTML neural network is used. What is MTML? It's multitask, multi-level. Now, multitask means the same neural network will be solving multiple tasks, predicting the probability of like, comment, save, share, and so on. So, and it's a very heavy architecture, as in there will be multiple layers, and also it will take into account the powerful cross features, which is user cross item features, which has not been used till now. So I want to emphasize a bit on that, like this cross features. So what happens in uh, the two tower model, which is the retrieval phase, we know that we will finally chop it off and use it in this way, right? So we pass the user features, we pass the item features, but we never get to pass user cross item features, that for this user, depending on the media category, how relevant that media category is, that this user may be more interested in cricket uh, category, we never get to use those kind of cross features because the user and item features are kept separate, the two towers are separate. But in case of ranker, you can use the powerful cross features which we are missing. So let me explain these cross features. So for user, we won't have the media features, right? Because the user might have not seen this media, but we can have the media category features, as in this media will belong to some broader category. It can be cricket, or it can be news, it can be something like tech or so on, right? For this user, how much relevant this category is, and you can have features around user cross category. Similarly, this user may not have interacted with the media, but you know that user belong to which cohort of users, and for this cohort of users, how the interaction with this media has been. So you can have media cross user cohort features. In two tower model, where you don't have that capability to add these cross features, because it will just blow up, and you don't know that which user can come in user tower, which media can come in media tower. But here, since you know that these are the hundred of items, and you can have a very heavy and more powerful deep learning neural network, you can have this kind of cross features as well, which will help you learn the task better. And task here is like predicting the probability of click, predicting the probability of like, and so on. And it's multitask, multi-level. Multitask we have already seen. Multi-level means that even for like, you can have like or not, like 1 0, and also if the user spends time, you can consider it as partial like. So there can be multiple labels or values 0 1 2 for a task. So in that way, it's a powerful, heavier, multitask, multi-level deep neural network model, which uses even the cross features, a part of that, definitely using the entity features. So this is how the ranking happens. It will give you different probabilities, and then you can calculate a function. Expected value is equal to, you can give some weighted combination of different probabilities and come up with a value. And you can rank order items in descending order of this value. And this, that is how your Instagram media recommendation works. From retrieval phase, the relevant media comes, and in ranking stage, in the first stage, you further filter out the most relevant ones, and then the rank ordering comes from this neural network, which will give you probabilities, and that will be weighted to come up with the final function. So with that we have covered the Instagram explore recommendation system. Next, I will talk about, jumping to Twitter and Pinterest recommendation system, which are like very smaller part, not as big as the Instagram recommendation system. I will talk about one more thing, and I think this is very relevant for this particular conference. That why deep learning based rankers, and with ranker I mean this kind of ranker model, right? why deep learning based rankers are outperforming tree based rankers in case of recommendation system. And if you think about it, and if you do more research around it, there are mainly three reasons why deep learning models are overpowering these tree based models. The reason being, the first is use of embeddings. These deep learning models are taking maybe the id based features and calculating the embeddings. Embeddings can be added in your model in two ways: either you can use already the pre-trained embeddings as a feature or fine tune it in the process, or you can learn embedding in the ranking process, ranking model only, right? But one thing is that they use these embeddings which are capturing the latent features for id based features and non id based features as well. So embeddings provides that extra edge to these deep learning neural network ranker models. Second is that I was talking in the beginning that even the sequential pattern of the interactions are used, like those clicks, views, for an e-commerce company, the product add to cart, click and ordering, how the flow is coming. We also look at the sequential pattern, that how these interactions are coming, the order in which they are coming, and we apply this attention mechanism or transformer module to it to learn more richer representation. So another advantage that this deep neural network have is the use of this attention mechanism to learn more richer representation or more richer embeddings. And finally, also the goodness comes from multitask multi-labels. So you are having one neural network which is finding probability of like, click, um, and comment, share, and so on. So the neural network has been exposed to more varied pattern data, right? So it has that ability to learn from multiple tasks, and each task may have multiple labels. So model learns multiple tasks, and that introduces it to more varied pattern in the data and learn stronger representation compared to a tree based model. So these are the main reasons why these deep neural networks are winning over a tree based model. But still, if you are starting a startup and you don't have a lot of data, I will suggest you start with simpler models, and when you become a bigger company and you have more user data available, more interaction data available, then you can shift to these deep neural network models, which will give you an extra edge and gains over your previous models. Next, we'll quickly look at Twitter's recommendation system. For Twitter recommendation system, we will just look at the retrieval phase. We won't go to the ranking model. So for Twitter, we will look at the who to follow recommendation, that is account recommendation. You can also draw similarity between this and Facebook friend suggestion, where it asks, give you suggestion that add friend request, give send friend request to these persons, right? So how does Twitter suggest that which are the users to follow? So it's called account recommendations. Who to follow is a critical piece that helps people connect with accounts relevant to their personalized interest. So for the retrieval phase, what they do is they again use a two tower model, but here the two towers are user cross user, right? And like, it makes a lot of sense when I explain it. So they are, what they are doing is, for the same user, we will have a consumer tower and a producer tower. The idea is that the consumer tower will analyze users consumption behavior, while the product tower or producer tower will gather the users production behavior. And it makes a lot of sense. I will give an example. As a content creator, I create content around data science. So as a producer, my content is more around data science. But once it comes to consumption, I consume data science, I consume tech, I consume movies related posts, and I am a big martial arts fan, so I consume what's going in the UFC world or mixed martial arts world. So as a consumer, my pattern are different, and when I produce things, my producer, I only produce in data science content, so my producing features are different. So that's the main idea, that for a user, we will have their consumption behavior. For the consumer tower, the personalized features of the users will be used. For example, what they are interested in, what they liked recently, which location they belong to, what are the topics they are interested in, this kind of personalized user features. And for the producer tower, we look at what they have produced, right? And as well as whatever they have produced, we can do an aggregate over the audience which have liked it. So what is the properties of the audience which are liking the comment they have, which liking the content they are producing, and some follower aggregates features. So that is what we have jotted it down. Producer tower leverages aggregate audience characteristics and incorporates graph based features to more effectively capture user producer attributes. And the idea is same, that once you have for all the users their consumption and producer features, you can have their consumer embedding and producer embedding. You do a dot product. If for a user consumption pattern is very similar to what if other user is producing, then you can recommend them as a follow person, that you can follow this person. So that's the idea. And how to train this model? You can take the following relationship from historical data and use those labels to train your model. And you would know where the user followed, and some random users you can also use for label zero, that they didn't follow each other, right? Because those are just random users. You can use a zero label, and the actual following relationship of the historical data as one label, and train your model and see in the out of time that validation, that how good your model is performing. So this is how the Twitter who to follow recommendation works. You have the consumer embedding and producer embedding, and consumer which are most likely to convert to a producer because of similarity in their embeddings are recommended in the accounts recommendation. And then once we have all the retrieved users which can be recommended, there will be a ranking phase which will just rank order them in terms of conversion. Enough of recommendation system, ranking, and retrieval. Now we'll look at a slightly different part of the game, uh, which is satisfying the business constraints. So let me explain it this way. The scalable recommendation systems are built using retrieval and ranking phase to optimize for conversion. But sometimes business may have different objectives, and those objectives also have to be satisfied. These business objectives can be something like also give visibility to fresh content or new users, or something like you have a platform, till now you only had images, but now you are moving towards videos as well, and you have limited videos. So how can you boost your video content by b percentage, like at least b% of the views should go to your video content, and in the last example the fresh content should get at least a percentage of the views. Similarly, sometimes what happens, there are deals between companies, and you see that for some of the sale, Amazon would have sponsored would have sponsored recommendation for a particular brand and so on. So when there are this kind of collaboration with a group, there are needs that at least c percentage of the views have to be provided to them. Sorry. Yeah. So this business object constraints can come on top of your recommendation systems, like fresh content has to be given a percentage of views, some specific type of content has to be given b percentage of views, or sometimes some specific group has to be given c percentage of the views. Now how to achieve this, exactly this percentage of view contribution, or give these these type of groups uh, exactly this much percentage of views share in your platform? One way is that you can give them slots, right? But as your objectives increases, it becomes impossible to give slots to everyone, right? And let's say you have 10 such constraints, how would you manage slotting? So what companies usually do is, after you have that uh, after your recommendation system, once you have the rank ordering of the items, uh, that this is the rank ordering in which user will be shown this item, what you can do is you can boost and demote the ranking scores. So basically, I will give an example. Like this is your final value, right? This is your final output or final score value you have after this calculation. What you can do is you can make some adjustment in that score. You can either increase for some item you can decrease it in such a way that this constraints are satisfied. And what is that more structured way of boosting and deboosting? There are some ways in which you can implement a controllable distribution, and one such way is PID, which stands for proportional integral derivative. The idea is very simple. If you have to give a percentage of the views, you can start with some views, and if you are giving more views, you will reduce the score for that group so that the views reduces over the time. So with time you continuously have a feedback mechanism which is based on PID. P stands for proportional to the error in actual views you need to give and what is the views you are currently giving. I integration, so you look at the cumulative error till now, the sum of errors till now, and D is derivative. You look at the rate of change of error. And what is error? Error is just that how many views percentage has to be provided and what is the current views going on. So in that way you can come up with simple error and have this feedback mechanism which at every time period will boost or demote the scores in such a way that finally all your constraints are closely satisfied. So and it works great. Companies use it a lot, this kind of controllable distribution on top of your recommendation systems score to satisfy the business objectives. With that, like I would like to conclude whatever we learned in today's session, or the I would say the main highlights that I would like you to remember. One is that the modern day scalable recommendation systems are built in two phases: retrieval phase and ranking phase. Retrieval phase retrieves the relevant item out of millions of items, and ranking phase rank them in order to better the conversion. And second highlight would be for retrieval phase, two tower based neural networks are used a lot due to its generic nature and cacheable properties. Cacheable properties means, the as I was showing, the two towers can be chopped off, one can be offline, one can be online, right? And also you can do fast approximate nearest neighbor search. So because of this, these two tower based retrieval models are very popular. Now coming to the ranking phase, deep learning models are bringing state of art performance. And why these deep learning models are bringing state of art performance and beating traditional ML algorithms like tree based and all? Because of these three things. One is use of embeddings, use of sequential nature in the interaction data, the order in which the user interacts, and also the goodness of multitask multi-label data makes these deep learning models a winner over the tree based models. And finally, on top of the recommendation system scores which are built to maximize the conversion, when you have to satisfy additional business constraints, you can implement a controllable distribution, something like PID, to satisfy uh, the business constraints, which can be around a specific group or content or some other business ask. So with that, I would like to conclude my session, and I would be happy to take any questions if there. So, what is the type of? I can see some questions on the chat window. The first question is, what is the type of input for model, like images, text, and number? Yeah, that's a good question. Like so for different type of content, you can come up with the features, right? And image can be one of the features. So what you can use it, what you can do is you can use image embedding along in the media tower, or in the as a image or media feature. So for image you can use the embeddings of it. And for text, what you can do is, as I was saying, like for Instagram kind of profile, I will just stop sharing. For an Instagram kind of company where you have lot of hashtags, now you can't convert each hashtag into categorical variable. I mean, it can be a one categorical variable, but converting back into one hot encoding may not be possible, right? So what you can do is you can uh, cluster these hashtags and provide the cluster ID as one of the features. Or other thing that you can do is, even for the hashtags or description, you can pass it through the embedding, some pre-trained embedding, and use this pre-trained embedding as a feature. So for text and images you can use embedding, and for number you can just pass the numerical features as it is. And finally you have all the features for that particular entity. And also I would like to say that people are using this cross entity features as well, right? User cross media cohort and media cross user cohort. Is input in .csv file for user tower? uh it it depends how you are implementing it, right? Like you have lot of data, you can batch stream it and all. So it depends on how you are implementing it. And mostly what I have seen is that, like in this scalable systems, like all the features are kept in Redis, which is like a very fast cacheable database. You just, as soon as the user come to the platform, you have just some milliseconds to show recommendations. So you quickly retrieve the features from this Redis and other this kind of databases, and then you pass it through the model. And model is also exposed as an API. You quickly pass it through the model and get the probabilities, get the final bunch of items that needs to be shown to the user in the same order in which they used to be shown, and push it to the app in which they will be visible. Which user engagement metrics are considered most important in refining recommendation on Instagram? Yeah, I would like, this question is very good. I think I should have a slide around that as well. Maybe I will talk about it. How will you analyze how good your recommendation system is, right? So there can be two ways. One is that, I would say there can be three ways. While training the recommendation system model, you can look at the ML metrics, which is accuracy, precision, recall. For recommendation systems, there are metrics like NDCG, and mean average precision, and so on. So you can look at this ML metrics. But when you are designing these recommendation systems for companies, industry, you also need to look at business metrics like daily active user, monthly active user, how's the GMV of the platform trending, how the revenue of the platform trending, and how your slot utilization is, whether you are able to utilize all the slots or not. So these are some of the business metrics you can look at. And also, with time, is, are your recommendations doing okay or not? What you can do is, uh, you can look at the drift in performance with time. And you can also look at some other metrics like diversity and so on, that how diverse your recommendations are. For a Instagram kind of app, there will be a lot of medias, right? So it should not happen that only 20% of the media are getting lot of user attention, remaining 80% are not getting. So a good recommendation system is one which is more democratized, as in the 80% or 90% of view share is going to good percentage of media. So in these kind of metrics also, you can judge the performance of your recommendation system. So summarizing it, you need to look at ML metric, business metrics, and some fairness or good to have metrics in recommendation system like diversity, serendipity, freshness, how fresh your recommendations are, and so on. And also you need to look at the drift, whether the system is performing well with time or not. Would love to take if there are any more questions, and anyways, you guys can connect with me over LinkedIn, and I have a channel as.
Hello there. Nice talk. I have a quick question. How do you handle robustness? Yeah, let's say because this has a lot of things related with money, I would try to tweak in the recommender system so that I can make more money, right? So how do you handle such kind of attacks?
Yeah, it's a good question. So I would again give the example of Instagram, because it's a safe thing to talk about. I don't work for Instagram. It's safe to talk about it. So you would see that in Instagram there are many sponsored ads that comes in between. One way to increase your money or revenue is just keep showing more ads. But what will happen because of that? The users will drop off, because they won't like it. After every two posts, you are seeing an ad, and sometimes if it's a non-ski, you can't skip it, then it's even more deteriorating uh, uh, your uh, your engagement with the platform. So how do companies balance it? They have to find the right trade-off between this kind of revenue and user engagement. So it doesn't happen that user engagement takes a hit and churns out of the platform. So you need to have these continuous measures. One way is that you can have a continuous AB. Some bunch of users only seeing the best content, they are seeing no ads, and you can compare it with that uh, bunch of users, that how the conversion of the users which are seeing ads is. And you can have some hard business thresholds, that more than 1% conversion drop or engagement is not drop is not acceptable. In that way, you can have this kind of continuous monitoring as well, and you know what is the right trade-off to show ads and all. And one more thing that can be done is, like, it's not like you can't show a lot of ads and you will if you show more ads you will lose on money. What you can do is you can have personalized ads, right? For example, if the user likes cricket content and some advertisements or sponsored ad is around advertisement and it's engaging, you show that to user. But if you are showing that cricket sponsored ad to some of the user who doesn't know anything about cricket, the conversion drop is more. So you can show more personalized sponsored advertisements, and secondly you can, as I was saying, you can keep on monitoring what is the drop because of ads or sponsored contents and find the right trade-off. And also I know of some of the platforms like Amazon and all where the sponsored items perform better than the non-sponsored items, and there they show lesser ad just so that other suppliers or other type of items also get a view. Otherwise they can earn even more without any conversion drop because their sponsored items perform very well. They just do it to be more fair to the suppliers and provide more visibility to other items as well. So depending on the platform, depending on how your conversion is and how good your personalization is, you can find that trade-off.
Yeah, that's a very nice answer. But that addresses how your revenue model works from the Instagram or Misho kind of app. But my interest is like I am interested in making my things being received more. So I will deploy some SEO techniques, and then I would try to tweak in your recommender system. So that is what I am interested in knowing, like how you would counter that. That's what I mean by robustness of your model.
What do you mean by SGO?
Search engine optimization techniques.
Got it.
Yeah, similar kind of things that I can try to use here for a recommender system, and then tweak in and see that my things are pushed more, so that I can make more money or become more.
Mhm. Mhm.
Yeah.
So I would answer it that this way, that many content creators do that. They know that which are the keywords which are more trending. They start using those keywords. Or if you know that which trend is going viral, they start creating content around it and it gets more views. So one way is definitely you know what is working well on the platform, and that you can know by doing a lot of experiments, as in with your content. You can see that what is trending, and when you make content around it, you also get a lot of views. Because even I am a content creator in YouTube, and I see that when I create something around this the latest language models, training a language models to mimic like Sadhu Khan, or training a smaller, fine tuning a smaller llama model, it gets more views than my content on recommendation system. So one way is that you know that what is working well, what where the converse you are getting more conversion. And secondly, your question was that how can you trick the system, right? So I would say the systems actually supports that if you are using the right keywords and all, you will get more conversion. And they look at other patterns as well, that if you have a very catchy tagline, then people may come and see your content, but they may not like it because actually the content is not that good, but the title is very catchy. So this kind of biases the recommendation system have to deal with. We have to train recommendation system to overcome the biases like clickbait and all those things. But if the content is good and it has used all the right keywords, it's in a right way, then you will get extra boost. So my point is, if your content is good and you're using the right keywords, trendy reels you're creating around that and so on, you will get more views because that is how the platform is. But if it's more clickbait but the content is not good, or something like something like your title is something but video is something different, those kind of robustness has to be there in recommendation system. And it's more around how can we overcome those biases. So I today only I released one video on overcoming biases. I can have one session around that as well. But yeah, that's my answer, that that biases has to be countered, but some other things which enhance your content because of the right keywords and all, that the system will support.
Thank you, Abhishek.
Thank you.
One more question in chat box. Can you please check?
How do I build recommendation chatbot which suggests based on a knowledge base? correct? So I think this is more around the latest LLMs which are going on, that how can you build a chatbot based on your data. So there are two ways in which you can build it. One is you can use a RAG, retrieval augmented generation. The idea is that your knowledge base, you divide it into chunks, and each chunk will have an embedding. When the query comes, you will find that which chunks are more important, and with the query you pass this context, or context in the sense that the most relevant chunks, and get the answer. This is called retrieval augmented generation, we used with LLM. That is one way you can create your chatbot on your database. The uh, second way is you can fine tune the LLM on your on your data. So many companies do it. So why is it done and why is it useful? Let me explain. I will explain. So when I was talking about that RAG, one problem is that you have to divide your data into chunk. How do you know what is the right chunk size? First thing. Second thing, how many top chunks will you send? Three, four, five? And also there is a limitation in the context window, right? Like the context can be of 4,000 tokens or 2,000 tokens. You can't send all the relevant chunks as well. So there are some limitations. What you can do, what you can do to overcome those uh, limitations is you can fine tune the model based on your knowledge base. And how companies do it? They do it in two phase training. The first phase, you just take your document and do a next word prediction only. In that way, you have inserted your knowledge from your document into the LLM. So you just doing the next word prediction, and then you can have one more level of fine tuning based on one more level of fine tuning based on conversational data. Then you will have to train it on conversational data, so that the knowledge that you have injected in your LLM is conversational in nature. To make it conversational in nature, you will have to do that Q&A kind of fine tuning. So finally your it can give you can ask questions and give answers. So that is how companies fine tune on their data by doing a first phase next word prediction, and second phase question answering fine tuning. And also, like, if you are finding good enough output with retrieval augmented generation, the way I was talking about, using this like passing the relevant chunks in context, and there are libraries for it like langchain and llama index. If your performance is good enough, you can do that. But if you feel that your knowledge base is very huge, then you can do the fine tuning. Always be, should a recommendation suggestion chatbot? Not necessarily. Like, LLMs are performing better in chatbot kind of use cases, but before LLM also chatbots were there, right? People were solving it using their own models. So definitely you can have your own models to first generate, understand the intent, like what is the intent of the user, and depending on that intent from your document, which are the relevant solutions to suggest. So people were building these chatbots before LLM as well. But what has happened post LLM is they are more they are more advanced algorithms. They understand human language, English language, or multilinguistic multiple languages well. So they perform better because of their capability to understand the language and bring that general intelligence to chatbot. If we are using LLM as chat, should it be fine tuned at QA? If we are using LLM as chat, should it be fine tuned at QA? I didn't get this question actually. Can you just unmute and explain? Hello.
Yes, sir. Hello.
Yeah.
Am I,
Hi. Yeah, you're audible.
like what I'm asking is if I'm using as LLM as a chatbot, some kind of echo is there once.
Mm, can you repeat the question?
Yes, sir. I'm coming from this another account. Like I'm offline student attending this Wadla. Uh, if you're trying to use this LLM as a chatbot, like it should be fine tuned to this any question answering data set or any type of LLM should be used when converting it as a chatbot. Like can we directly use this LLM to like a chatbot, or is there another step to while converting a chatbot? What is main difference between this chatbot and LLM, and what is conversational AI? Like these are my questions. I was
Got it. Got it. Yeah. Got it. So what happened was like these GPT models were available in past as well, right? So what they are trained on next word prediction, that given a context, it is able to predict the next word. But they are not uh, conversational in nature, as in you can't give it a question and expect an answer. So what OpenAI did was they trained it on question answering dataset. They did one level of fine tuning on question answering dataset, that given this question, what should be the response. And when that the first stage training happened in next word prediction, the LLM had already learned the knowledge that is given a context. What is the next word? And when you think of it, it's like it is understanding the language, and it is able to predict the next word because it has learned how English language works and how the words comes together. But it was not fine tuned on question answer. It was not conversational in nature. So what OpenAI did, they did one level of fine tuning on question answering dataset to make it conversational. So even if you go to open this Hugging page and try to download models, you will get both the base model and a chat model. The base model is the one you can one which is not conversational in nature. If you ask it what is the capital of uh, India, it can give you capital, or it can start asking another question: what is the capital of Pakistan? What is the capital of France? Because it is just trying to complete the next word in the sequence. But when you teach it that no, we are trying to get an answer from you, and then it become conversational in nature. And OpenAI used a lot of other techniques like RLHF, using the human feedback to better train it on question answering kind of scenario. So that is how this conversational chatbot you get it. So sorry, conversational LLM you get it, and then you can use these RAG techniques or and so on to train it and make it a chatbot.
okay, sir. Thank you.
If there are, if there is just 2 minutes, I would like to show something. I will just share my video. Sorry, share my screen. So this is a blog from NVIDIA. So what NVIDIA did is, in this blog they have talked about the these transistors and all. They are calling it transistor cities, as in one of the, okay. So yeah, under yeah, so you can think of it as city because tens of billions of transistors are connected, and they are thinner than a human hair. And what you need to find is that how to connect these transistors to solve particular kind of use cases, and it's like a city in itself. Now what they wanted was, like, people who join NVIDIA, they will have a lot of doubts, right? Many kind of questions. They wanted to train a chatbot on their knowledge, which is how these connections transistors are connected, and like any generic questions which can come on people mind or the developer's mind, and which some other developer would have solved in past. So what they wanted was, they wanted to train an LLM on their data, so that finally they have a conversational LLM where the developer can ask questions around building these chips, and it can be answered quickly. So how they trained it is the part that I would like to show you. See, so the team refined the model in two training rounds. In first round, they did simply the next word prediction. They first using 24 billion tokens. So it's like they just trained a next word prediction, and in the second training round, they trained it on conversations, that is question and answers, and they mixed both normal conversations and design examples. So that is what I was explaining, that how companies train this data on their databases, they do two levels of fine tuning. One is just do next word prediction on their data set, and then to maintain the conversational nature, they fine tune it on conversation data, and that can be a mix of general English language like how are you or what is deep learning, along with some of the, in case of Nvidia, some of the design examples, design Q&A. So in that way they finally come up with conversational LLMs. I have a lot of videos on conversational LLMs on my channel that also you can check out.
Yeah, sir. Thank you.
Thank you very much, Abhishek. It's really nice to talk with you. I hope if the participant will raise a question, we will reach you through mail or something else. Hope you will never for that one.
Definitely. Thanks, Dr. Rakesh, for inviting me.